let's talk about the mole. So, kind of a weird unit, probably not something you thought of as a unit before you get into chemistry, but in chemistry it's really, really important. And actually, it's a quantity, okay? So we can talk about a dozen of something, and if I say a dozen, I know that you know that would be 12 of something. So for example, 12 donuts. We can talk about a couple, and you probably know that that's 2. If we talk about a mole, to a chemist, they immediately think of this number, 6.02 times 10 to the 23rd. That's called Avogadro's number, named after the guy that derived this value. And that's a different video for a different day. But what you need to know is that a mole is just a quantity. So if you have a mole of something, you have 6.02 times 10 to the 23rd of that thing. So in this box, I give you the example of molecules. We can also talk about atoms. You could talk about electrons. We don't tend to talk about things that are relatively large on the atomic scale, something like a donut, because if you had a mole of donuts, you could make a planet of donuts, and that's just kind of silly. And we haven't made that many donuts in the entire existence of the planet. But what it does allow us to do is it allows us to think about these really, really small things, which come in very, very large amounts, in ways that make sense to our brains. So one way that we can do that is we can relate a mole of something to the mass that a mole of that substance takes up. So we are thinking about that usually in terms of elements or molecules. And so you find those values on the periodic table, okay? And let's talk about an element first. So if you have a mole of helium down here, a mole of helium is 4 grams. So we can actually count out a mole of helium by using its mass to do so. It's called counting by mass. And so we have, if we have 4 grams of helium, we know we have 1 mole. Now, if you look at molecules, then you use the same molar masses off the periodic table, but you multiply them by their subscripts. So here we have O2. So oxygen has a molar mass of 16 by itself, but oxygen's always diatomic, so when we're talking about O2, then we have 32 grams. So we can measure out oxygen that way. Okay? You can also get into much larger molecules and calculate molar mass with those. I am going to do a second video on calculating molar mass of molecules, so stay tuned. Another way we can measure moles is by using the volume of a gas. So if we have a gas at 0 degrees Celsius and 1 atm, then that will always have a volume of 22.4 liters. And so that's another way. Gases can be hard to get the mass of, but we can easily get their volume, and so we can use volume to calculate quantity of a gas there too. So there you have it. That's what a mole is. It's really just a quantity, but because it's such a large quantity, we measure it in other ways. And that's my first video in a series that we're going to be doing on the moles. Stay tuned.